So, have you ever stopped to wonder how your computer knows the difference between a number, a letter, or just a simple yes or no? Well, in C++, it all comes down to data types. Think of them as the different kinds of containers you use to store all your information. Today, we're going to crack open that C++ toolbox and take a good look at these essential containers.
Think about it this way. Imagine you're packing for a move. You wouldn't put a fragile wine glass in a flimsy paper bag, right? Of course not. C++ is pretty much the same way. When you create a variable, you're not just grabbing any old box. You have to tell the compiler exactly what kind of box you need. Is it a tiny little box for a single character? Or is it a big, sturdy one for a massive number? That is the fundamental question we're answering today.
And the answer, of course, is the data type. It's basically the blueprint. It tells the compiler exactly what kind of stuff you're working with, so it knows how much space to set aside and what operations are even allowed. You get this part right, and you're well on your way to building solid, reliable programs.
I really love this analogy of data types as the tools in a programmer's toolbox. Because just like you would never use a sledgehammer to hang a small picture frame, choosing the right data type is absolutely crucial for building software that's both efficient and, correct.
All right, let's open up this toolbox and start with the basics. These are your primitive types, the real hand tools of C++. We're talking the hammers, the screwdrivers, and the wrenches that you're going to find yourself using every single day.
So these primitive types, they're like the standard issue tools that come with every kit you buy. They are the absolute foundation of your C++ work, the tools you'll be reaching for in pretty much every project you tackle. First up is the integer, or int as you'll type it. This is your trusty hammer. It's the workhorse for anything that involves whole numbers. It's perfect for counting things, indexing, just your basic everyday math, and on most systems today, it takes up a tidy 4 bytes of memory. But what happens when you need to work with fractions or decimals? Well, that's where your floating point types come in. A float gives you about 7 digits of precision, which honestly is great for a lot of applications. But if you need that extra bit of accuracy, say for financial or scientific calculations, double is your go-to, with around 15 digits of precision.
And here we go, the C++ data type cheat sheet. This slide lays out all the most common primitive types, showing you exactly how much memory they typically use and the range of values they can hold. This is a good one to keep in your back pocket. It'll help you always pick the right tool for the job.
Okay, but what if you need a more specialized tool? That's where type modifiers come into play. Think of these like the different attachments or bits for your power drill. Short and long can change the size of your number, while signed and unsigned decide if it can be negative. For instance, an unsigned int can't go below 0, but the trade-off is it can hold a much, much larger positive value. Pretty neat, huh? Now for a couple of real specialists. The bool type is basically a simple on-off switch. It can only ever be true or false. It's perfect for making decisions in your code. And char is your super simple tool for storing just a single character, like the letter A or a pound sign. And finally, in the primitives, we have void. Now this one's a bit of an oddball because it represents the absence of a type. You'll see it all the time with functions. If a function just does something, like it prints a message to the screen, but it doesn't need to hand you anything back, its return type is void. Okay, so we've seen the hand tools, but what about the power tools? Let's talk about the derived and user-defined types that let you build your own custom solutions and really get creative. The infamous pointer. Let's walk through this because it's actually not that scary. First, look here, we create a variable x and we put the value 10 inside it. Simple enough. Then we create a pointer, which we'll call PTR. And in this final step, this is the magic. We tell PTR to store the memory address of x. So PTR doesn't know that x is 10. It has no idea. All it knows is where in the computer's memory to find it.
So the key takeaway is exactly this. A pointer holds an address, not a value. Now, this gives you a ton of control and power over your memory, but it also means you have to be really, really careful. Always make sure your pointers are actually pointing to something valid. What if you need to store a whole bunch of things together? Well, that's what arrays are for. They're just like a row of identical boxes, all lined up neatly next to each other in memory. They're simple, they're super fast, and they're perfect for managing lists of data. All right, now for the heavy-duty custom tools, structs and classes. They both let you create your own complex data types by bundling other types and even functions together. The key difference, and this is a classic interview question, by the way, is that in a struct, everything is public by default. In a class, it's all private.
So the rule of thumb is to use structs for simple groupings of data and reach for a class when you really need to control access and protect that data. And then there's the union. This is a very specialized and, frankly, a potentially dangerous tool. In a union, all the members share the exact same spot in memory. This can save you some space, but it's like having one single box that you use for everything. If you put your lunch in it, you'd better be darn sure you took your greasy tools out first.
Now, the tools we've looked at so far are incredibly powerful, but some of them can be a little dangerous if you're not careful. The great news is that modern C++ gives us a whole new set of tools that are way safer and easier to use. So let's check out the modern C++ toolkit.
Okay, here's a common problem. You've written a function, but it might not have a value to return. Maybe it's searching for something in a database, and it comes up empty. What do you do then? How do you represent nothing?
Well, in the old days, you might have returned a magic number like -1 or maybe a null pointer. But what if -1 is a perfectly valid result? The modern C++ solution is std optional. It's a special container that either holds a value or it's empty. It's a crystal clear and totally safe way to say, hey, I might not have a value for you. And remember that dangerous union we just talked about? Modern C++ has a much safer alternative, std variant. It's like a union, but it's smart. It always remembers what type of data it's currently holding. This completely prevents you from accidentally trying to read a number as if it were a letter, which, trust me, can cause some of the strangest bugs you'll ever encounter.
And honestly, the modern C++ toolkit has a solution for almost every common problem. Need an array that can grow and shrink as you need it to? Use ctdis.vector. Need a fixed size array but with more modern features? Use ctdis.array. Need to store any type of data in a type-safe way? ctdis.any is your friend. Using these modern tools is just going to make your life easier and your code a whole lot safer.
So when you boil it all down, choosing a data type is so much more than just a technical detail. It's about writing code that's efficient, that's safe, and that's easy for other people to understand. It's about communicating your intent to the next programmer who looks at your code, who, by the way, might just be you 6 months from now.
You've got this whole toolbox full of data types at your disposal. So the next time you're writing some C++ code, just pause for a second. Think about which tool is really the right one for this specific job. Are you reaching for a sledgehammer when a tiny screwdriver would do? Making that conscious choice, that's what separates good code from great code.